What is current transform? Imagine trying to measure the massive flow of water in a huge river. Directly sticking a small measuring cup into the torrent wouldn't be practical or safe, right? A current transformer, CT, is somewhat like a clever device that helps us measure these large electrical currents safely and conveniently. Think of it as a special type of transformer that is designed not to change the voltage significantly, but rather to produce a secondary current that is a scaled-down, accurate representation of the primary current flowing through a circuit. Here's a simple way to picture how it works. The primary current. The high current we want to measure flows through a conductor, which acts as the primary winding of the CT. Sometimes it's just a single pass through the CT's core. Magnetic field. This primary current creates a magnetic field around the core of the CT. Induced secondary current. This changing magnetic field induces a proportional alternating current in the secondary winding, which has many more turns than the primary. Safe measurement. This secondary current is much smaller and safer to handle, allowing us to measure it with standard instruments like ammeters, or feed it into protective relays and metering devices. Key things to remember about current transformers. Step-down current. Their main purpose is to step down high currents to measurable low currents. Series connection. The primary winding is connected in series with the circuit whose current needs to be measured. Proportional output. The secondary current is directly proportional to the primary current by a known ratio, the turns ratio. For example, a CT with a ratio of 100/5 will produce 5 amperes in its secondary for every 100 amperes flowing in its primary. Safety. They provide electrical isolation between the high-voltage primary circuit and the low-voltage measurement circuit, ensuring the safety of personnel and equipment. Secondary must be loaded. It's crucial that the secondary winding of a CT is never left open-circuited while current is flowing in the primary. This can lead to the development of dangerously high voltages across the secondary terminals and can damage the CT. So, just like our river analogy, the current transformer allows us to tap into a large and potentially hazardous electrical current, take a safe and manageable sample, and accurately understand what's flowing. They are indispensable tools in power systems, industrial applications, and anywhere accurate current measurement is required for monitoring, control, and protection.